In this topic, we focused on the types of information contained in a diagram legend, and we followed a system diagram as we looked at the components of a plant system. Try some questions now to practice what you've learned. There's a separate section on this legend for the different kinds of line symbols. This symbol represents the flow path of material through the system, and these represent instrument signals. This arrangement allows flow to bypass the flow indicator if necessary. The symbol for the valve in the bypass line is filled in to indicate that it is normally closed during system operation. Electrical diagrams typically include symbols for the major components in electrical systems. These components include transformers, motors, and other components that use electricity, and the protective devices associated with the system. Electrical diagrams also show the connections between the components. This is an example of a one-line diagram for a simple electrical system. One-line diagrams are frequently used to represent electrical systems or individual sections of systems. They use a single line to represent the transmission path for power through the system. We'll look at the components in the main transformer section of this electrical system. This is the symbol for a power transformer. It is the main transformer where power comes into the plant. The transformer converts the incoming high voltage from the distribution lines to a lower voltage that is used within the plant. This symbol represents a current transformer. Current transformers are frequently used to supply current at a reduced value to devices such as ammeters and relays that are used to monitor and control the power in the system. This transformer does not affect the current flowing from the main transformer to the rest of the system, but it does allow the current to be measured. This is the symbol for a circuit breaker. It is closed to energize the system supplied by the main transformer and opened to isolate the system. The symbols shaped like chevrons indicate the circuit breaker can be physically pulled out of the system to isolate the circuit, as you see the technician doing here. There are 6 circuit breakers shown on this diagram. In many cases, electrical components are represented by circles or boxes that contain numbers or letters. For example, a circle labeled A represents an ammeter, a device that measures the flow of electric current, and a box labeled AS represents an ammeter switch. The switch is used to open or close a circuit to the ammeter. These and other abbreviations used on electrical diagrams can be found in a standard diagram abbreviations table. Many electrical devices are identified by number codes rather than letters. The number 51 here indicates that this symbol represents an AC time delay over current relay. The numbers related to electrical components can be found in an American Standard Device Function Numbers table. The electrical system in a plant is designed to carry electric power throughout the plant. The heart of the system is the load center, or main bus. A bus is basically a conductor that connects a power source to several load circuits. Load circuits supply individual loads with power from the load center. A load can be a device such as a motor that uses power, or a device like a transformer or a motor control center that supplies power to other circuits. There are 3 load circuits connected to this load center: a lighting circuit, a motor circuit, and a motor control center. On this diagram, motors are represented by circles containing the letter M. A load center includes devices that monitor and control the power that's being distributed. Voltage is supplied to these devices at a reduced level by a potential transformer. A voltmeter switch, labeled VS, is closed to allow this voltmeter to measure the voltage of the load center bus. Low voltage can damage electrical equipment, so an undervoltage relay, represented by a circle containing the number 27, is used to open the breaker at the main transformer if the voltage gets too low. Opening the breaker isolates the 480-volt bus and the load circuits connected to it. This diagram also shows a motor circuit that is connected directly to the load center. It is equipped with a breaker. This current transformer supplies power to an instantaneous overcurrent relay and a time delay overcurrent relay. They open the breaker in the motor circuit if current flow is too high. This symbol represents a contactor. It is used to start and stop the motor. The motor control center is basically a bus similar to a load center. It supplies power to several load circuits, but a motor control center generally supplies power only to motors. This motor control center includes two motor circuits. For each motor, the diagram shows a motor start circuit that includes a potential transformer, a fuse, a motor contactor, and a start-stop switch. The arrows indicate that the contactors are operated by the start-stop switches. The diagram we've been working with represents a rather simple electrical system, but by now you should have a basic idea of the types of symbols used on one-line electrical diagrams. Try some questions now to check your understanding of electrical symbols. A load center includes devices that monitor and control the power that's being distributed. Voltage is supplied to these devices at a reduced level by a potential transformer. The motor control center is basically a bus similar to a load center. It supplies power to several load circuits, but a motor control center generally supplies power only to motors.